welcome. Today we're going to be preparing you for CVSA's Brake Safety Week coming August 25th through the 31st. My name is Aaron Lehman with Visons, and my goal today is to give you some knowledge, skills, tips, and tricks necessary for you to avoid getting any brake related violations through this safety week. It's a lofty goal, but I think we can do it. So, with that, I'm going to try to keep this short and sweet and dive right into it. So this is the FMCSA's list of the most common vehicle maintenance related violations under their CSA program. And the way I'm going to structure this training is to focus in on the brake violations within this list. So these are the 5 most common brake related violations. And we're going to go into detail on each one and give you all the tips and tricks necessary to try to get in front of these and avoid getting these violations out on the road. As you can see, it's just general brake related violations: brake hose chafing and kinking, reserve system pressure loss, and then the last 2 are related to brake adjustment. So you get a brake out of adjustment and you get a slack adjuster failing to compensate for wear. So we're going to go into detail on all of these, starting with brake hose chafing. How to spot chafing can sometimes be difficult. What you want to look for is discoloration where the hose may be touching an object. That's your first sign of chafing, and that is what the DOT is looking for. Watch for change in shape or a flat spot where the hose is touching an object. As you can see here, a long flat spot streaking across the hose, good sign of chafing. If nylon is beginning to show, that is a very bad sign that you've chafed all the way through the rubber and now you're exposing the internal structure of the hose. And then watch for bulges. These 2 examples are pretty extreme. They're not always this extreme. They can be a bit more subtle. But oftentimes, especially when a pressure is applied, a badly chafed spot can bulge. So watch for that as well. How to spot kinking can be a little bit easier because, similar to a garden hose, it's pretty obvious when a brake hose is kinked, which is going to disrupt airflow and cause you issues. Watch for twisting in the hose. Sometimes lines can start twisting, and what will eventually happen is that it will coil and kink, as you can see in this rather extreme example here. And then hoses often kink near connection, especially if the connection is too tight. So especially in this first example here, this hose connection was too tight and it kinked. At some point, this glad hand connection point was pulled to one side, causing a major kink, which scarred the internal structure of the hose, and the kink remains even if the line is straight. That line would need to be replaced. How to prevent hose chafing and kinking? Do not let your air brakes touch the catwalk. This is the number 1 cause of hose chafing violations. If they're rubbing, install a hanger or mounting bracket, or both, as many companies do. Wiggle the lines during your pre or post trip. See if they can easily hit something. If they can, use spacers, loom, or rubber wrap to protect them. There is no limit to the amount of these protection devices that you can use under DOT, so use them liberally. Make sure lines aren't too loose or too tight. Remember, loose lines will cause them sometimes to coil and kink or to be able to move around during operation and rub against an object. Lines that are too tight can often kink around connection points. Most importantly, inspect and correct as soon as you see an issue. Do not let an issue become worse or it can get you an out of service violation. All right, moving on to those brake adjustment violations that we referenced. This is the brake readjustment limit chart taken straight from the regulations. What it does is break down by brake chamber size and then their stroke length limit. So the most common brake chamber for a tractor trailer is going to be a 30-inch, 30 by 30, so 30 for the spring brake side and 30 for the applied brake side. And then the long stroke chamber is very popular. So that would give you a stroke length limit of 2.5 inches. That's when you apply the brake, the push rod cannot travel more than 2.5 inches to apply that brake. Now, how do you know what the brake stroke length limit is? You want to look at the brake chamber. It should tell you right on it. Now, I want to talk, even though this is more of a mechanic thing than a driver thing, the best measurement method for the brake readjustment limit. Because even though you're not going to be doing this as part of your pre or post trip, it's really good to check and make sure that your maintenance department is doing the proper measurement method. Otherwise, you're opening yourself up to a brake adjustment violation. So the best method of measurement is without a doubt the mark and measure applied brake method. It really is the only reliable means. So as you can see in this video here, you mark the push rod, apply a full pressure application of the brake, and then measure again and mark how far the push rod traveled. It's important to note that this is how the DOT inspectors measure adjustment, so you may as well do it the way they do it to help avoid that violation. The least reliable method of measurement is going to be the visual inspection of angle between the push rod and the slack adjuster. This is common in the industry. They take a glance at it, looks close enough to 90 degrees, must be within adjustment. Way too many variables for this to be an accurate measurement. A couple less reliable means than the mark and measure applied brake, not as bad as the angle measurement. The free stroke method using a wrench or pry bar where you pull on the push rod and see how far you can make it travel. Or the parking brake method where you simply apply the spring brakes and measure how far it pushed the push rod out. Neither method provides enough pounds of force to get an accurate measurement. Now, why exactly does pounds of force make a difference on the measurement? Well, under a full 100 plus PSI brake application, you will have deformation of the brake components, expanding of the brake drum, and compression of the brake pad, which lengthens the stroke. So this blue line here would indicate where the brake stroke would be if the brake pad was touching the drum, but with how much pressure a full PSI application gives, you actually get some deformation, which is going to make it go a little bit farther, which I will show you in this picture here. So this is where the push rod was when I had the spring brake applied. And this is where the push rod was when I did a full pressure applied brake method. And you have over a 1/4 inch of difference, nearly 15% longer with the applied brake method. So moving on, routine inspections and maintenance of slack adjusters is probably the driver's best way of preventing these brake adjustment violations. First and foremost, grease slack adjusters every 6 months or 30 to 50,000 miles. Slack adjusters do not compensate for wear properly if they are not properly greased. It's good for the driver to give the slack adjusters a tug every pre or post trip to ensure that there is no more than 1 inch of play. If there's more than an inch of play, there's a good chance that when you fully apply the brakes, it is going to travel too far, that push rod. Because what that's really measuring when you pull on it is how much gap there is between the brake pad and the brake drum. And if there's more than an inch, then once that brake is fully applied, it's probably going to go beyond its adjustment limit. Routinely perform leak down tests on every pre or post trip. Those leak down tests where you measure when your spring brakes pop out and measure when your low pressure warning alarm comes out, which will be a video later in this presentation. Why would that make a difference on your slack adjuster? Well, slack adjusters need hard braking to actually adjust. And what happens is when you're experiencing soft braking highway driving, you're wearing down those brake pads, but your slack adjusters are never being kicked into gear. And so when you're doing those leak down tests where you're hammering that brake over and over again, that is a good way to keep your slack adjusters adjusting if you're never running into hard braking situations. There's another option you can do, which has come to be known as the 6-pack method, where you let your primary and secondary systems get up to 100 plus PSI, hammer the brake 3 times, let the system recharge, hammer the brake 3 more times, and that's a good way to kick those slack adjusters into gear to adjust for that wear. Now, if the above is all adhered to and the adjuster still isn't compensating for wear, there is likely an issue with the slack adjuster or the brake components. Manually adjusting is not a permanent fix. It is only temporary and therefore should be avoided. If it's not readjusting, bring it up to maintenance. So moving on to system pressure loss. Major causes of air brake pressure loss would be poor glad hand seals. This is the #1 cause actually. Replace them yearly or whenever the airlines are replaced. Polyurethane seals last longer than rubber because they're more impervious to open weather conditions. Get the pie cutter mesh style ones I often encourage because there's been so many stories of dirt, bugs, spiders, building webs, so on and so forth, getting in the hose lines and causing pressure issues. And they're not much more expensive and they can prevent those from happening. And then lastly, get a replacement pack for the truck. It only takes a screwdriver to replace. So if you hear a leak coming out of a glad hand, it's great to have a replacement pack in the truck. Swap it out within minutes. Moisture and contaminants in the air brake lines can cause pressure issues, especially in freezing temperatures like up here in Wisconsin. Ensure the air dryer cartridge is replaced roughly every 200,000 miles or 2 years. Purge the air tanks at least weekly to drain the moisture. If excessive moisture escapes, it's a sign the air dryer needs replacing. And then finally, avoid or limit the use of airline antifreeze. It can cause damage to the internal seals. The internal seals are not built to endure that chemical. So I would avoid using that product altogether if you want to avoid pressure loss. Bad repairs. So I took these pictures directly from the CVSA's website. These are real world examples of out of service violations. You have an airbag leak being fixed with duct tape. You have a male to male end connector for a brake hose that was severed. And then you have a master lock in place of a clevis pin. All sorts of ways in which you can have really poor, shoddy repairs done on your truck. You're responsible for the unit. If you see a bad repair that you don't trust, do not operate the unit. Great way to avoid major violations out on the road. And then finally, normal wear and tear is going to cause system pressure loss. Brake lines and connectors, airbags, brake chambers, purge valves, governors, so on and so forth, they all have a service life. Troubleshooting brake issues as soon as they arise is the best way to catch parts reaching their service life before they reach failure. And that's why I encourage carrying and familiarizing yourself with an air brake troubleshooting cheat sheet. Real easy to keep this 2 to 3 page document in your cab and reference it if you have goofy stuff going on with the truck. The best one that I've found on the internet can be found by Googling suspension specialists air brake troubleshooting. It's just a couple page PDF. Here's the front page of it. And it goes into detail on all the different types of air brake issues that you can have and gives you so much good information on how to troubleshoot yourself while out on the road. So, inspection processes to prevent system pressure loss. Do your brake pressure checks every pre or post trip. And I have a video demonstration on the next slide on how to do that. Check your tractor protection systems at least once a month or once a week. Which I also have a video demonstration on the next slide on how to do that. And then listen very closely while inspecting for audible leaks. Diaphragm leaks are very common, but they're notoriously hard to hear. That's where the internal diaphragm of the brake chamber begins to leak, this rubber here. And since it's inside the brake chamber, it's very hard to hear. So if you're inspecting in a noisy yard, there's a good chance you'd miss it. But when the DOT is inspecting, it's a good chance they're going to hear it. Continue listening and observing while you are operating the unit. Most air brake issues arise after your pre-trip. Remaining observant to your vehicle will allow you to note the issues on your post-trip. If you hear, see, or feel something unusual, say something. All right, now I'm going to show you the video on the in-cab brake and emergency spring brake pre-trip inspection. All right, today we're going to be doing a quick demonstration on how to conduct the in-cab portion of your pre-trip inspection on your air brake system and your emergency spring brake system. There are a few things that you need to have in place before you begin the inspection. First, you want to make sure the unit is on flat ground with the wheels chalked because you're going to be disengaging the parking brakes and losing all pressure in your service brakes. And when that happens, you want to make sure you're not going to be rolling away. Second, you're going to want to roll the window down. In the event that there are some leaks outside, you're going to want to be able to hear them. Third, you're going to want to have the engine running as you can hear so that you can get both your primary and secondary systems to their maximum 125, 130 PSI. This unit's at its maximum right now, so we are good to continue. Fourth, you want to disengage both parking brake knobs. And then lastly, you're going to be turning the engine off and then turning it halfway on into accessory mode. This is an important step. All right, now that we are in accessory mode, we're actually already beginning our first inspection, which is going to be the static brake check. Static meaning that you're not going to be putting any pressure on the brake pedal. You're just going to be watching the primary and secondary gauges and ensuring for a combination unit like this one that you're not going to be losing more than 3 psi over the course of 60 seconds. For a single unit, you want to ensure you're not losing more than 2 psi over the course of 60 seconds. And for sake of speed on this video, we're not going to actually wait the 60 seconds. We already checked that on this unit and it did pass. So then the next one is going to be the applied brake inspection, where you're, as the name implies, going to apply the brake. You're going to lose a little PSI right away, and then you're going to begin your 60-second check to ensure that for a combination unit, you're not going to lose more than 4 PSI over the course of 60 seconds. And for a single unit, you're not going to lose more than 3 PSI over the course of 60 seconds. And again, we already checked this unit, so for sake of speed, I'm not going to wait the 60 seconds. This one passed. If your unit does not pass, it's an indication of a leak that should be brought to the mechanic. All right, with that out of the way, we're going to go ahead and move forward with the leak down check. This is by far and away the most important check among all these different inspections. The leak down check, as the name implies, is going to require you to leak down both systems and make sure that 2 important things happen. So by leaking down, we just simply repeatedly press the parking brake, or I'm sorry, the service brake, and we're going to want to make sure that when it hits 60 psi, that your low pressure warning alarm goes off. And then as we continue further, between 20 and 45 psi, we want to make sure that both parking brakes apply, or emergency spring brakes. As you heard there, they both applied, and that concludes the leak down check. This unit has passed. All right, for the repressurization test, we're going to want to make sure that this unit goes from 85 psi in the primary and secondary systems to 100 psi when your RPMs are at 1400 in no more than 45 seconds. So I'm going to get the RPMs up to 1400, and I'm going to watch the gauge and start counting up. All right, this unit managed to get there in about 25 seconds, so that indicates that it does have a functioning air compressor. If it takes longer than that, it should be brought up to the mechanic. Moving on now to the tractor protection system self-inspection. All right, today we're going to be demonstrating how to conduct a tractor protection systems inspection on your own unit. There's a few things you have to have in place before you head on over to the glad hands and begin the inspection. First, we want to make sure that we're on flat ground with the wheels chalked, which we already took care of on this unit, so we're good there. Second, you want to make sure both your primary and secondary systems are at their max PSI 125, 130, which this unit is, so we are good there. Third, we want to disengage both parking brakes. Once they're disengaged, you can then turn the engine off and head on over to the glad hands to begin the inspection. So to begin your trailer protection system inspection, we're going to be removing the glad hands. Make sure to watch your eyes. All right, as you can hear, that stopped fairly quickly. If it does not stop, that is an indication that your trailer supply valve is non-functional. You want it to stop before your primary and secondary systems fall below 20 psi. So we're going to go ahead and check and make sure that it is above 20 psi. As you can see on this tractor, the valve activated at 60 psi, so it passed this portion of the inspection. So if you were to have fallen below 20 psi, that's an indication again that your trailer supply valve is non-functional, and that would be an out of service condition. The next thing we want to check for is to listen and make sure that no air is coming out of either of these couplings. If it is, that's an indication that your trailer spring brake control valve is non-functioning. That is not an out of service condition, but it would be a violation. No air is coming out of these, so we are good. Then we want to make sure that the emergency spring brakes activated. If you don't hear them activate, go back there and check by making sure the push rod is rock solid. As you can see, the emergency spring brakes did activate. So it passes that portion of the inspection. If they did not activate, that would be an indication that your trailer breakaway system is not functioning, and that would be an out of service condition. All right, now the last thing that we need to check for may require a helper. It requires that you push the service brake and make sure that no air is coming out of either glad hand. Without a helper, you can simply pin the brake like we're going to do here. Get yourself a pry bar. You can also do it with a 2x4 and pin it. Lower the chair, and as you can see, it's going to push the brake down. All right, now that we got the brake applied, we're going to listen, and these are not leaking, which is what you want. If they were, that would be an indication that your towing protection valve is not functioning, which would be an out of service condition. And with that, that concludes the tractor protection system inspection. Only takes a couple minutes, and it could save you from getting an out of service violation. All right, just a couple more slides left. Other brake issues to check for. Check brake lining thickness. It must be at least 1/4 inch thick. Check for a situation known as rustjacking. It's where you have rust building in the brake shoe, which is especially common in areas with heavily treated roads with the highly corrosive salt and other materials to de-ice. What will happen is the rust will jack up the brake pad and cause extra pressure at that point, which can lead to cracking or chunks coming off of the brake pad. Check for brake lining cracking or brake lining voids. Watch for grease around the brakes. Oil leaks most commonly happen on the inside of the tire, and it is a violation to have oil or grease on the brake pads. Now, this oil leak is probably because the gasket blew in the hub, but you can have more subtle leaks than this. You got to watch closely for them. All right, and then to wrap it up, I want to talk about performance-based brake testers. If you haven't seen one of these yet, more than likely you will. There's a good chance you would see one during the Brake Safety Week. So, some information about them. They've been measuring braking efficiency at inspection stations since the 1950s, and they have over 100,000 in use in North America today. They have them hardwired into inspection stations, or they have mobile ones. And they calculate by measuring the slow speed brake force divided by the total weight of the vehicle to generate an overall braking efficiency percentage. Anything that falls below 43.5% efficiency is out of service, even if no brake violation is found. And that's all I have for you. Thank you so much for making it to the end. I hope you learned something, and I hope you feel more prepared to make it through this CVSA Brake Safety Week with no brake-related violations. If you have any questions, please feel free to call or email me directly. My contact information is here, or you can contact my colleague, Nick Poloni, as well. Thank you so much, and I hope you have a wonderful week.